I want to thank you all for attending tonight, this Nova Software Quality Engineering and Automation Meetup. My name is Jonathan Kaufman. I work for a company called Coveros. And I'd also like to welcome the host of this meetup when it's held in person. Becky Love King from Fannie Mae usually works to help host this in Fannie Mae's Reston office.
I just wanted to say a special welcome to any of the Fannie Mae people that are able to attend. We did advertise this within the company, so as we usually do with the on-premise meetups, we usually have a good percentage of people that are able to make it. So I want to welcome any of the Fannie Mae people.
Thank you, Becky. And then I also wanted to let you all know that we're always looking for new speakers. And we've been holding these meetups at a quarterly cadence, so we'd be looking for a speaker for around the November timeframe. So if you or someone you know has a talk that you'd like to give, please feel free to let me know. I also want to quickly introduce two upcoming events that Coveros has going on. We have buy one, get one free on our live virtual training courses through the month of August. It's a great opportunity to help improve your skills, to make you ready for the next opportunity that you have, or just to make you more adaptable given these unpredictable times that we're living in. I'll go ahead and paste a link to that in the chat as well. And then finally, the Star West Conference, a testing conference that you may be familiar with, is going to be held completely virtually this year. It'll be held from October 5th through October 8th. There's both free and paid attendance options that will fit any budget you have, even if you have no budget. So if you're interested, please go ahead and click on the link to the conference website in the chat. If you have questions during the presentation you don't want to interrupt in order to ask, then please feel free to pop those in the chat. We'll be sure to go through those at the end when doing Q&A. With that, I will stop advertising and hand things over to our speaker for this evening, John Hill, Senior Automation Engineer at Ansible, who will be telling us about life after Selenium. Take it away, John.
Cool. All right, so today we're going to talk about life after Selenium. My name is John Hill. I work at Red Hat Ansible, which means I guess I work for Red Hat, Ansible, and IBM now. But I've been doing UI testing for about 6 years now using Selenium, and it's what I enjoy doing. I'm out of the Raleigh-Durham area, and I guess now I'm at home, so I'm in the Durham area. But yeah, we kind of, the Ansible team looked at all the different frameworks available when we restarted our UI testing initiative for a new UI. So I'm kind of just here to share what we learned along the way. And in this talk, what you're going to see is you're going to see Selenium browsers, what their problems are with both. We're going to ride the wave and talk about what that means. We're going to go over the new solutions and walk through a test in 3 different frameworks, the same test, 3 different frameworks, talk about what happens next, and leave 10 minutes at the end for Q&A. But specifically in this talk, I'm not going to convince you to delete and restart what you're currently doing. I'm not being paid, at least I don't think I am. We're going to just skip over mobile. We're not going to talk about all the alternatives out there. There's a lot more than I'm presenting on, especially some of the newer stuff. And this is JavaScript only. We're not going to touch on Python or Java. So, Selenium. I think we're all familiar with it. It's a way for automating. It's an open source tool that allows you to automate browser interactions for web applications. So I'll repeat that again, automate browser interactions for web applications. And so that's really where it starts and ends. When you talk about the operating system, you kind of lose control, but it's great. It was created in 2004, a long time ago, and is now maintained by the Selenium HQ organization. And nowadays, Selenium refers to the infrastructure and tooling to run WebDriver. So Selenium is now decoupled from WebDriver, and WebDriver is now a part of the official W3C browser spec. So the same specifications that allow you to click on a button and have it appear on your screen, that's the same built-in specification that drives Selenium and WebDriver. So it's awesome. So it's it took a long time. I believe that became part of the spec in 2018. but it did it. So now we're cross-browser by definition. Cross-browser right out of the gate. It works on any browser that calls itself a browser. And to pop open the hood a little bit, what we're looking at here, left to right, you have your client libraries speaking to WebDriver speaking to your browser to your web app. Again, so right to left, you have your web app. So this could be whatever you're developing internally. This could be google.com. Communicating via REST HTTP to your browser. So that'd be Chrome, Firefox, IE, Safari. That is communicating via REST HTTP to WebDriver, which is a binary that sits somewhere. It could be Chrome, Gecko, Safari, any one of these drivers, and that speaks to your Python, PyTest over the JSON wire protocol-ish. Now that it's, well, we'll just say JSON wire-ish. So this is what Selenium looks like today. You have your PyTest communicating to the WebDriver. The WebDriver is communicating to the browser over RESTful HTTP calls. That browser then goes and does everything that a browser does to talk to your web app. And so that's pretty important here. Can you guys see my my mouse move around?
Yes. Yes.
Awesome. Okay. So what is the WebDriver driving? Well, we talked about it's driving a web browser. So a web browser serves up web applications. It consists of a rendering engine for JavaScript. So for Chrome, that uses the Blink. I believe it's Gecko for Safari or for Firefox. And there's multiple rendering engines that interpret JavaScript. And then that then displays what you see on your screen. It allows you to see and interact with websites. So the browser restricts the web app code in HTML, CSS, and JavaScript. Then with that code, it sends XHR requests to your web app or google.com, which are HTTP traffic. The browser uses any data that comes back to reconstruct or originally construct the DOM, which is kind of how everything is laid out internally inside of the page. And then at that point, you handle any changes that occur. So initially the DOM being loaded or a mouse click fires an event. That event goes, it's processed by the browser and then sends an event to your web app. And then you have this another chain of whatever you want to do. So this is a lot, and I'm not the best at describing this. So I'm actually going to pop out of this and kind of just show you a real application. So this is called the Cypress Real World App. So you can get it just by going to Real World App, download it, install it. And I'm going to use this as an example to kind of drive maybe what most of us use today. And it's a great way to just kind of test out, testing. It's ultimately what they do to test their tests. So it's pretty cool. So this is running in the background here on one of my terminal windows right here. But yeah, so it's got a login page. We all know and love it. You have your username, password field. You click sign in. So if I remembered what the password was, which I don't, which is why I have it saved, I would type in the username, type in the password, click sign in. This click fires off an event that then loads the page. Then I would go to new, which fires off another event. Click search and watch this. So we'll do, oh, what have I ordered recently? Amazon. You guys just saw my Amazon. Okay, so we have dev. So dev, typing in DEV, it restricts the search to this, just these options. So I'm going to open up the Chrome Dev Tools to kind of take a look at what's going on throughout this whole thing. So we have the Performance tab here. So I'm going to do the, actually, let me just go to the Network tab really quick. So we have, let me reload the page. So by doing this, you get to see these are the XHR requests as they come across. So we are querying the API to get information about the users, notification, bank accounts. And this is something that I think we all deal with day to day. And you can in time here. So we're going to take these dev tools a little bit further. And this is all built into Chrome. So we're going to record what we're about to do, and we're going to type dev on and then stop. And the profiler should see that we stopped the profiler should, okay, it's not going to see it. Okay, so the profiler should have seen that we stopped. And what we're going to see now is we're going to see what the internal rendering engine sees. And so in this case, it's actually you're able to use the timeline functionality to see what the browser sees. So look at that. Let's go look at time. So left to right, you can see how it's changing. So we have the summary of everything that's occurred, the timing. Let's go look at, let's see, timings, network. So here we go, looking at network here. How do I see the network requests as they come across? Okay, so you can see here in time, it's actually probably very difficult to see, but you see what it's doing. It's sending individual HTTP requests to users search DE for Devon. Then it receives another mouse event and is searching for DEVON. And in the background here, you have, let me get rid of,
but here you can see so what we can't see right now is the click event. Let's see if I can capture it, put it back in time. Okay, bad demo. Sorry, I'm a little off right now. But yeah, so what you would see in this call log is you would see the mouse event as it's being triggered. So it's usually a mouse click on. That's a native event that the browser recognizes when I click on here, and that's manipulated and handled within JavaScript. So let's pop out of here and kind of review what we saw. We saw a browser. It downloads CSS, HTML, and JavaScript. It handles the initial DOM loaded event. It fires off XHR requests to the API. It renders and paints what we can. So if you remember this tab here, you're seeing what's being rendered and painted. And then as new information comes, like you saw, it repaints new information. And so this is great. This is kind of how the modern web works. The reason it does this in this order is it can take some time for the network request to come back, depending on how far away your web app is. So you often want to show something to the user. So instead of waiting for the last transaction to occur, you show something in between. And that's kind of how it's working now. So let's take a moment to then talk a little bit about what it means to be cross-browser. So I think, so we looked at what a browser is, but let's talk about kind of what cross-browser means. So we have, you probably have heard this a million times, we need Selenium because we need cross-browser testing. Ultimately, that comes from someone who's probably never maintained a grid, which is, for those of us who have, it's kind of painful. But we know that Selenium is cross-browser. And what does that mean? Well, it means that you can have one Chrome driver manipulating Chrome, Gecko, Firefox, and you can basically manipulate the major browsers because remember, it's WebDriver is now part of the W3 spec, and you can test just about any browser that you would want to test on just about any operating system. And here is a view of all of the APIs that are changing. So not only are there different browsers to test, but you have different versions. And I think most of us are familiar with these different versions that we have to test. So here's Chrome 86. Here's the features coming. Here's 84, which is where we're at now. And that's kind of what we're testing between browsers, and that's what it means. But what you create is effectively you're creating this matrix of browsers to test, where you have each browser type going across, each browser version going down. Then you take another dimension, which is each operating system and operating system version. And this gets pretty big. So here's Testing Bot. So Testing Bot provides the infrastructure, the Selenium infrastructure, to run Windows 10 with Chrome Beta 83, 81, 87, all the way through Firefox, all the way down, IE, all the rest. And so the matrix is actually very large, and there's a lot going on there. That's really what the power and the draw of Selenium has been up until now. But as QA testers, we're really just testing, when we're testing browser versions in the matrix, versions, APIs. We solved some of the APIs, the different rendering engines in WebKit, Blink, Gecko. And we're testing, does the app then work with each browser API or each operating system? So those are kind of what we're testing when we're talking about cross-browsing. So cross-browsing is critical for many, and we're going to talk about that in a little bit, but we have more problems than just that. Selenium allows cross-browser testing, but it has a lot of problems. You have to manage a lot of different things to get that working. So you have your framework, your test runner, you have Celanese language bindings, the binary, the version type, browser version type, capabilities, and you basically have all of these different things that you need to manage when using Selenium just so that you can run your test on one browser version against your web app. And there's a lot to manage, and so that's a problem. Thankfully, Docker Selenium solves a lot of this. So the Docker Selenium HQ project will basically wrap all of this together. And you basically just have to worry about your test framework working with the language bindings that we talked about earlier, communicating to WebDriver, and that's where your concerns more or less end, thankfully, nowadays. But there's still a lot of problems here. So we talked about this diagram. So remember, this is the diagram of client, library, WebDriver, browser. Well, in between here, this is RESTful HTTP, so this could be any network traffic, and there could be any distance here. So when we were looking at Selenium on the Ansible side, we set up this test to study network delay. And we use this chaos engineering tool called Comcast, which simulates terrible network conditions. And what that allowed us to do is kind of control network latency. So here's the entire test suite running in 2 minutes with no latency. If you see my mouse, we simulated any distance between the driver and the browser. And in our case, we simulated each of these 25, 50, 75 milliseconds. And then that became 5 minutes and 21 seconds for the total runtime of the test. That is to say, the same test, same everything, same infrastructure. If you move your browser away from your test framework or Jenkins, your tests just take longer naturally. And it's pretty extreme. So this is over a 200% increase in test runtime. And we didn't do anything. We moved to where the browser was. And so why is 75 milliseconds important? Well, 75 milliseconds here is Sauce Labs. So if you're going to use Sauce Labs, you're introducing 70 milliseconds of delay between, in my case, my machine and Sauce Labs, but it would be Jenkins and Sauce Labs. So right off the bat, if you start to use an external grid or you use anything that's external to your Jenkins, you introduce this performance penalty that's really significant. And why that is, it's because you're the observer. You are ultimately, as Selenium, you are just observing things that are going on. You're not actually technically controlling anything that the browser is doing internal to the browser. Just very quickly, it's very expensive to run Selenium. JMeter is a popular load testing tool. If you want to use JMeter to run Selenium versus API tests, you have to budget a 1,000-to-1 ratio. That is to say, if you're going to run JMeter on a machine, it needs to have, it can run either 1,000 concurrent API tests or a single Selenium test. So that's kind of puts the ratio into play there to help you see how expensive Selenium is to run. And if you want to see, a video of what's going on or a screenshot, you need a plan for it. So you need an additional core, additional gigabyte of memory and storage to run this. So that's really expensive. Fortunately, we talked about cross-browser. We looked at one testing bot. This is Sauce Labs. They can manage it for you. So in this case, you can run 24 tests at the same time, but it's going to cost you almost $5,000. That's huge. That kind of puts into play how much it costs to manage this infrastructure for cross-browser testing, for cloud-based testing, and just managing Selenium browsers on your network is expensive. But the last thing we're going to talk about is what I think most of us are familiar with when we talk about Selenium. We talk about flake. UI testing is flaky. It's often difficult to understand why the tests fail. You can add screenshots and videos, but we talked about that. It's expensive. And Sauce Labs themselves published a video where they said you can expect that 3% of your tests are going to fail, and you're just going to have to live with that. So why is it flaky? Well, it's not event-driven. So WebDriver is just sending requests, stateless requests to the browser here. It's polling for events, WebDriver is asking the browser, has this happened? Have you clicked yet? Have you seen this yet? Has this event loaded yet? And you're just listening for events. There's this loose coupling between what's going on here, between WebDriver and the browser, and you have no idea what's going on between the browser and the web app. This is where Selenium stops right here. You have no idea what's actually going on here. You're just getting inferences of that in your tests. And ultimately, it comes down to a lack of observability, and you have this loose coupling between your tests and your web app and what you're trying to do in between. So let's go ahead, and just take a look at this. So we have, I'll attach it to this presentation, but I have a GitHub repo here that has a Selenium test, and it's going to do what we looked at earlier. It's going to initialize the web page. It's going to test just some simple things, the title of the web page. It's going to then find the username, enter in the username, enter in the super secret password, click the submit button. And this is, a standard Selenium test, I think what most of us are used to. It's then going to click that button, if you remember, that new button I clicked on, verify that it exists, and then it's going to enter, something, it's going to enter dev or devon vector into that search query that we looked at earlier, and then wait for that to equal devon vector. So the syntax here isn't too important, but it's a general flow of what we did earlier. So let's go ahead and do that. So I'm going to pull up my terminal here. I'm going to go back to Selenium, and I'm going to do npm test. So we're standing up a browser, a real browser. We're entering those things, and we're clicking in. It failed. It failed to. You can see the assertion here that when we searched on that search filter, we did not see devon vector. So let's go ahead and do what we all do. Let's add a wait and see what happened at that stage. So it completed this successfully, but it failed to assert correctly here. So let's go ahead and do what we all do. Let's add a wait. Let's see. So we logged in. Okay, and there you go. So what you see there is the initial set of results for devon. It did not necessarily have the same items in the list. So let's take a look at this manually. So if we type in, we click new, let's go back and click new. If we type in devon, you see how the list is changing? The list is changing because if we look at the network traffic, let's go ahead and we are entering in new search strings. So it's searching for devon each time and re-rendering what the browser should see for the user to eventually filter down to devon vector. And so that I hope that kind of illustrates what part of the problems are with Selenium is you don't actually know what's on screen. You don't actually, more importantly, know that these requests have gone off in time and if the information that the browser needs to know about these is available. So the test was asserting effectively that when it started to enter anything here, that the first item was devon, and you can see there it was not necessarily. So let's go back to the test. And so taking a look at the summary here, there's a lot of dependencies without clear ownership of who owns what. So Selenium HQ doesn't own everything. They don't own the Python Selenium bindings, for example. We have speed and performance issue. We know that it's expensive to run. And we know that there's flake due to the loose coupling between the browser and the web driver. And we have, cross-browser. Is it a problem? Not really, but there are a lot of problems with, supporting that massive matrix. So just want to take a minute here to say that this is now stale. What everything you're about to see here is out of date, and this presentation has changed many times because things keep changing. So let's ride the wave. And this message is brought to you by Google, and you'll see why. So Remember, I said that Selenium came out in the year 2004. Well, on this graph, we're seeing 2007 to 2020. This is browser stats provided by the W3C organization that just takes the aggregate of all browsers that everyone's using for general network traffic, general internet usage. And you can quite see, 2004 is off the chart to the left here, but at that time, IE and Edge, and here they're bundled here, but it's really IE was the dominant player. You had some Firefox usage that peaked in 2010. They kind of crossed, and they all crossed in 2009 when Chrome came to join the game. And you can see quite clearly, what's happened since then. Chrome has really taken over. We have some people still on Safari, some on Firefox, and some, there's at least one person out there still using Opera. But you can kind of get the general feeling here that, things are changing and very clearly in one direction. And the best example of these changes, the best illustrated example is Internet Explorer. So Microsoft actually announced in late 2018 that they were going to stop using and maintaining their own internal rendering engine. Remember, we talked about those rendering engines. They said, we give up. This is just too hard to maintain. So we're going to just use Chrome. But not Chrome, we're going to use Chromium, the upstream version of Chromium. So just think of Chromium as Chrome without the license codec, so you can't Netflix and chill. But it effectively, Microsoft's default browser is now Chrome under the hood. It is basically a flavored version of Chrome. And I just want to call out, since we're all QA people here, that the upgrade path for enterprise customers is uncertain at this time. So when they go from old Edge to new Edge, they may not have a clear path. Another thing that's happened during that time is the modern frameworks have come into play. So Vue, React, Angular, that's all you hear about nowadays. It's kind of taken over some of the spot that PHP might have had. But, it's a good thing. So thick clients are gone. I think some of us have used VMware vCenter. Remember, you would go and you download this thing that it would install on your Windows machine or your Mac machine. And then that's your interface or user interface to communicate with VMware's stuff. That's gone. They switched all the way over to it's just web-based. Plugins are gone. Flash is not dead yet. I checked. Flash is not dead yet. But the modern web has replaced everything. And because of that, what we have now, more or less, is stability. So because everyone's migrating to these same frameworks, there's fewer rough edges. Another great thing is browsers are evergreen. Browsers are continually being tested. They're continually updating themselves. You don't ever have to worry about updating Chrome. I can't remember the last time I downloaded Chrome or Firefox. It just updates itself, and it's always working. And as a sign of this, I'd like to ask the audience, what browser version are you on right now? I think most of us would not know. So I think what we can do is kind of say, what is cross-browser testing now? Well, cross-browser testing now is actually, we can get rid of most of this. We can X out most of the parts of the matrix. Some of us still have to test IE11, and I feel very, very sorry for you in deepest part of my soul. And then, Edge, now look at Edge. We just have to focus on 84, and 84 matches, Chrome 84. So we're crossing things off. So the wave is Chrome's taking over. Evergreen browsers and the web has matured. What that means for us is cross-browser is less important. There are now fewer browsers, fewer rendering engines at least, fewer browser-based bugs because everyone's moving to the same frameworks. Chrome is driving this change. So if you test Chrome, you test the rest. And now you have an always stable interface. Chrome is almost always working. So let's talk about the solutions then. So we talked about the problems, and we got 30 minutes. So let's talk about the solutions. So what are some of the solutions? So first thing, got it right off the bat. There's a lot, but Puppeteer. So it's how Chrome tests Chrome. The Chrome dev team needs to test Chrome, and this is how they do it. They use Puppeteer, and to do that, what they've done is they've created not the WebDriver API, but the Chrome DevTools Protocol API. If you recall, we were looking at the Chrome DevTools, and there's a lot of power in there. You get to see everything that's happening at any given moment, the events, the network traffic, the rendering of how long things take to paint, and all of that is available to you if you use that protocol. So instead of using WebDriver, so in the same way, think about it this way. WebDriver is to CDP as Selenium is to Puppeteer. So Puppeteer is kind of everything that allows CDP to work in the same way that Selenium is everything that allows WebDriver to work. And the API is almost an identical copy of WebDriver. So and we'll look at that in a second. But it's evergreen. So like I say, Chrome test Chrome. So you just download this one. You download the library. It's associated with a binary of Chromium, and it's cheap. It downloads almost. It's incredibly quick to download. You just get the one binary. It works everywhere. It just works and solves a lot of the Selenium problems, especially the some of the additional API problems. And now Puppeteer has official Firefox support in the nightlies. So the Firefox team now supports Puppeteer natively, which is awesome. And again, it's not a framework. It is just a direct Selenium replacement. So let's just take a look under the hood a little bit. So awesome. So what do we have? What does Puppeteer really give us? This is all great, but what does it really give us? Well, it means that our tests can now be event-driven, that we have a WebSocket interface, a real-time WebSocket interface between our JavaScript client library and a real browser, It has almost zero impact from network latency. So you could run this browser wherever you need, but again, since it's so small, since it downloads so easily, it can just run alongside your test framework. And everything is real-time, everything is instantaneous. There's no wasted polling, are you ready, are you ready, are you ready? You just know everything you need to know that the browser does. And this is all via the CDP interface. And so what that gives you, now that you've exposed the CDP interface, you're now seeing the things from the perspective of the browser. You're seeing those XHR requests, you're seeing those DOM events, you're seeing everything that the dev team that makes Chrome work would want to know. And with that, the added bonus is you get to intercept and interact with those network calls. And we're going to take a look at that in just a moment here, but just a direct comparison here. We've simplified everything to just basically from these binaries that you have to work on the specific version with the specific flavor, communicating to the specific browser over the stateless protocol. What we've done is we've replaced this stateless REST HTTP interface with a real-time WebSocket, and no information is making it past here on Selenium. Nothing about what's going on here is making it past, but you get everything that's going on within the browser available to you in your tests. And again, we're going to take a look at that. But just look how similar, I think most of us are familiar with Selenium. Look how similar this looks. You're instantiating a page, you're creating a new page. Instead of visiting a URL, you just go to the URL. But here's a really cool thing. One thing you can do is instead of, most of us, I think, wait for an element to get displayed before we move on to the next part of the test. Because we're getting native network traffic, native browser traffic, we can just wait until everything calms down, until there are no more XHR requests firing, until the app is ready, and then we can move on. And that's really what we're doing here. We can wait for whatever we want. We can assert on anything we want. DOM events, the page, and this is where the flake goes away. You can now assert on anything. You totally understand what the browser is doing at any given point, real time, instantaneously. And so this is what CDP becomes. It's instead of losing the steering wheel, you have complete and total control, instantaneous control for what's going on in your tests. So the best example of this that I know to show is WebDriver IO from 2013. It's a holistic framework. Again, because Selenium and WebDriver are decoupled, it's actually just communicating via WebDriver. It's not Selenium-based, but it's, as we saw, it's pretty close. It's got a lot of cool things, auto-wait, auto-retry. But the reason I want to talk about it today, not because I'm recommending it, I would recommend it. It is a great tool, but I wouldn't recommend it over the others. It's just that Puppeteer is now the default. So WebDriver.io, their namesake is WebDriver, and they've seen the power that I talked about earlier, and now it is the default way of communicating with your test, and you don't have to change anything. You can just take your same test you wrote in 2013, and they work now with Puppeteer. And so let's take a look at that. So I'm going to open up the WebDriver .io test, and let's just take a look at this really quickly. Very similar to what we saw in the Selenium test. Again, look, you're inserting on the page title, you're clicking on the username element, you're waiting for the username element input to exist, you're setting the input value for the keystrokes onto the username field, you're entering the password into the password field, clicking the submit button. All of this is almost identical. There's nothing significant to this this test framework or any of the structure. It's all very, very much the same. But what we have here is we have the Selenium test, the test version. So same assertion here, right? We're waiting for the first element in the dropdown to contain Devon Becker. So let's go ahead and do that. So to do that, I am going to go back to our tests, and we are going to go to the WebDriver directory, I think, and let's see, what are we going to do exactly? I just want to make sure that's right. So we are going to go to this directory here, WebDriver, and we're going to execute test. So npm run test. So you can see this is all the stuff going on behind the scenes. So launching it, boom, bam, bam, failed. So same reason, exactly the same reason. The network request had not yet come back from the server, so therefore the browser was not ready to be interacted with. So that's the same exact thing we saw earlier. What we were testing against, what we were sitting for, just it wasn't ready yet because of the way the browser and the nature of the browser is sending network requests. However, we can add the wait. We can add the wait, and that'll show you the same thing. Or let's do it the Puppeteer way. So I'm going to set this test to skip. And you can see this is identical, except that we've done a little bit differently here. We are now able to intercept that network request. So we click on, we wait for that element, the search bar to exist. And now we are waiting for the server, waiting for the browser to receive this network request back from the web app with a 200 HTTP 200 bit. So the test freezes, quote unquote freezes. It's not waiting, it's not doing anything special. We're waiting for that condition to be true. And then we are moving forward with the test. So I misspoke. This is actually setting the definition of what we're going to wait for. We wait for it within this logic here. And this is just me not being necessarily good with this framework, but we are going to assert that this request is true. We're going to keep trying until that's true. So again, we wait for this element to exist. We set up the interceptor. We set the value of what we're looking for by typing in. Again, this is typing in Devon Becker. And then the test is not waiting. It's not pausing. It's not retrying. It is just listening for this state to be true. Then it's moving on with the test. So it's a live demo. Let's see if this works. So to execute this, we're going to do test Puppeteer. So np clear npm run test Puppeteer. And that's it. So there we go. We are actually from the perspective of this test, we can note we don't have to wait for anything. There's no more flake. There's no more indeterminate behavior. It is very much we are in the the driver's seat of the browser, and we're getting the elements back. And you can see everything that's going on within the browser here. We are getting real-time traffic from DevTools, and look how lightweight this is. It's just expectation result. You're just listening to the stream of information as it comes back. Let's see if I can compare that to, yeah, look at how noisy and chatty the Selenium is, of how it's waiting for everything, all the information that's being back. And so that's it. From my perspective, that's the easiest way I can demonstrate the power between the two. There's no more flakiness. There's no more indeterminate behavior. It is very much anything the browser is doing, in this case, executing REST HTTP calls, you get that information. You get to see it. Super cool. So let's go back. See what time is it. So we're going to go through very quickly here. There's not actually much to say about Playwright other than it's cross-browser quote-unquote testing done right, that's what they say. From January 31st, 2020, again, uses the CDP API. It's very controversial. Microsoft hired the Puppeteer team, literally took that team, probably paid them a lot of money, and moved them into Microsoft to basically create this framework that is basically a fork of Puppeteer. Interestingly, just want to call this out. It's the Firefox support is a fork of the Firefox Puppeteer project, but not the same one that Firefox currently supports. So it's a mouthful there, but it's kind of funny how this all played out. Interestingly, the only interesting thing I'd say about this is that it can run WebKit, which is the upstream Safari browser engine. So remember, Chromium is upstream of Chrome. Well, WebKit is upstream from Safari. So that means you can run your quote-unquote Safari tests on Windows or Linux. That's pretty cool. It's not a total framework. This is a direct replacement of Puppeteer. It's very easy to migrate to and from. But yeah, so this is basically Puppeteer with another check mark, which is Safari. So if we think back to that graph we were looking back at all of the different browsers you have to test, you're now covering, I think, all of them. I think this actually supports Edge, so you get Chrome, Firefox, Safari, and I believe you get Edge. So you basically get all of them. So when you use Playwright, you're using Puppeteer. It's almost identical. But you get to test all of the browser combinations on anywhere you're running it, Mac, Windows, or Linux. So let's do that really quick. Again, not a really interesting demo. So we're going to do the same thing here. You go to the Playwright. What we're going to do is we're going to run the same test here. You look at the syntax again. Very similar, almost identical. But you can see here we're going to wait for network idle. That's new. Calling that out. And what we're going to do differently here is we're just going to take a screenshot when we're done. But look how clean and similar the syntax is. Very nice, very easy to work with. So let's go to our default package.json, and we're going to go and get this multi-browser script. So let's go ahead and pull that up. Go to the default directory, npm run. So this is it running in Chrome, same test. Take a screenshot. Now it's loading up, what is this, Firefox. Running in Firefox, pretty cool. Same thing. But, here you go. I'm on WebKit, so I'm on Safari. It doesn't matter if I was on Windows and I just running my test. And I took a picture of what happened. So there you go. Proof that it exists. Again, not that interesting, but just if you need that additional, if you want to check it out, I recommend it. If you need that additional checkmark, you need Safari, there you go. But lastly, we're going to end in 4 minutes. We're going to end with Cypress.io. And I can answer more questions about any of these, but we can talk about this with you both. E1 from 2017 is proprietary. It does not use the same things that we talked about earlier with Puppeteer. It injects JavaScript into the browser, and that allows some really cool stuff that we're going to get back to. But it's not using C. It does use CDP, but not in the same way. So this is just thing about this is different. It has a premium OSS model, so you can use it for free, download it, use it, run it. Doesn't matter, you don't have to pay for anything. If you want to, you can. And when you do that, you get their dashboard service, which is pretty cool. You can take a look at that. It gives you a GUI playground to kind of mess around with, which is pretty cool. The documentation is out of this world. Everything is really well documented. It's an all-in-one solution, so it's more than a framework. If you're going to use Cypress, you have to go all in. So you could use Puppeteer with any framework. We saw it being used with WebDriver, for example. This is very much all-in-one solution. It's got Firefox and Edge if you want to run it. Let's just take a look. Again, it's pretty simple here. Let's go look at the test really quick. The tests have a really good, really clean syntax here. So we're testing the title. So because we can do some function chaining, you can make basically everything you do a single line. So it becomes very easy and clean to read, what this test is doing. If you remember looking back at these other tests, this is done in basically 22 lines. But it's pretty compact. It's very easy to read. You test that the title should be React App. Enter in the username, password. You type it in. You click the new button. And again, we're going to intercept requests here, just like we did with Puppeteer. With Puppeteer. You type this in, and we're going to wait for. Remember, we're going to wait for this to be true, and then we're going to move on with the rest of the test. Just going to do that really quick since we're running out of time. Let me go pull up the package.json. So we're going to test Cypress, and we're going to use the GUI driver, which is pretty cool. So we're opening up the GUI driver. You don't have to use this. Just makes pretty easy to work with. So here you can see you can switch between these if you like, Edge or Canary. You can run the test. Just go ahead and run the test. So same thing, sending into Chrome browser, running in the background. But this is where this kind of gets interesting. This is really interesting. We're seeing the test as it's written. We're seeing it running here, but remember I said it's injecting JavaScript into the browser? Well, what you get with that is you get a fundamentally different way of interacting with web applications. So what you get here is, remember I talked about the DOM? Well, what you're getting here is you're getting snapshots of the DOM. You're getting snapshots of the application in time. So I can click here and freeze, and I can see, the best example is maybe it'll show you where you click. So you can see what happens before you click, where it clicks, what happens after you click. After you click, it sends out, remember, we're talking about network requests. After you click, it sends out the API request, right? Remember? It's sending out all of this information. Look at that. You can actually see the actual requests that are being sent to from your browser to your web app. So let's take a look. Let's take a look at the one we were looking at earlier. So let's see how to get that. Yeah, there you go. So you can see the network request that we are looking for, the API request sent to the browser. And you can see everything else you need to know about it. So remember, we can assert on the status. We can do whatever we want, and there's not enough time, unfortunately, in this demo. You can probably see how much there is to cover. You can actually stub out these requests. So instead of waiting for real requests, you can tell the test, hey, don't look for that. Just pretend you got that, and then continue on with the test. And because you're driving the browser, you can do that. You can tell the browser, hey, this is what you really got back from the web app, and then move on with the test. So pretty cool. Yeah, that's Cypress. I mean, there's a lot going on here, but it's pretty powerful. So we can get back to the thing. And I know we're over, but we'll just go. We'll go over some cons. It's proprietary, so if you use Cypress and the Cypress organization goes down, you go down with the ship. Things will still run, but there isn't much open source. Can't work with iframes. Can't orchestrate multiple tabs. There is a penalty associated with cross-browser testing. So when they added 4.0, added Edge and Firefox, look how much longer some people's tests are running. Look at this. Their tests went from 2 minutes and 30 seconds to 7 minutes and 35 seconds. That's a huge difference. And all of it is because there's a penalty associated with the abstraction that we added. And so here is our test running. We are an open source project, so you can see them. So let's go see, where did this test fail? That's not a good example. But yeah, so here's all of our tests. Here's the dashboard, so you can see the test as it failed. You get a recording of it. Let's go back. You can show it to me. Yeah, so here's a video of the test failing, where it failed. Meantime, it's got screenshots. So all this is all of this is being uploaded to their service. You can see exactly how and where the test failed. pretty cool. You get analytics. You can see what the slowest tests are, the top failures by test. Really cool stuff. And one way I just want to call this out. One thing we did was we had this bug that had been around forever that bugged our Selenium tests. Basically, our first test, our smoke test, would fail at some absurd 1 out of 100 times. It would fail, and we could never figure out exactly what was going wrong. I closed the issue saying this will perpetually remain a mystery. After 2 years, we never figured out what was going on. But very quickly into using Cypress, look how much time went by. We were able to see exactly what was going on. Because we were seeing the network requests, we were able to see that, oh no, wait, the actual API response from the web server is giving us a 400 code. It's actually failing. And there's nothing our tests can do about it. There's nothing, it's a bug with the web app. And the actual web app team, the UI team is like, what do? We can't, this is how it comes back to the API, we can't really do anything. So what we did on our tests, we just retried these logging attempts, which has been pretty good. But what's happened is because we're using Cypress, and we have all this real-time browser interaction, we have all the real-time information, we have less dependencies and less maintenance. Our tests are now as stable, if not more stable, than the application that we're testing, which is really cool. We're in a really good spot. And if we want to, we can add cross-browser. So let's talk about the future. So that's everything. Let's talk about the future. CDP is a new standard. We talked about the fork of a fork of a fork, but not the same fork that the Firefox team is using. This is now new. WebDriver, when it came into being, Selenium came into being, there was no competing standard. There was nothing to compete against. Firefox, they just laid off 250 members of one of their teams, which is a third of their workforce this week. I think it was Tuesday. They're in a bad spot. If you are going to use, if you do care about cross-browser, one thing to do, this is what Ansible's Pendo data looks like. 80% of our users are using Firefox. The rest are Firefox Edge. There's literally one guy out there using Opera, and I want to talk to him. But what we do is we run Percy tests, which is a visual regression testing framework, to kind of catch the visual differences between builds, but also between browsers. So this is much more important to us that our tests, the rendering engine is ultimately what's different between Firefox and Chrome. So we actually just want to see what that looks like, the difference between the two. So this is an example of we did an upgrade, and these are all the changes. In some cases, we actually have bugs here. You can see all the changes that occurred when we upgraded here, but we get to see those in Firefox and Chrome. And ultimately, that's what we care about. The functionality between the two, the gap is narrowed. It's not too interesting. So what we're doing is we're leveraging visual testing for that. And to come full circle here, Sauce Labs and BrowserStack now offer Cypress tests to run in their cloud. So you don't have, so now you can run Cypress tests on Windows. We're right back to where we started, which I think is pretty funny. But the last thing I want to end with you all is Selenium 4. So, cool thing about Selenium is that your tests from 10 years ago probably still work. And that's a testament to the team, a testament to the fact that they went the right way with this. They baked it into the browser standard, and you can run the same test from 10 years ago. And a lot has changed since then. We've looked at everything that's changed. A lot has changed, but your tests still work. Your Selenium 1 tests still run on Selenium 3, and they will still run on Selenium 4. Crazy to think about. But, Selenium is missing a lot of things. And there was a tech talk that I was listening to where someone from Selenium HQ he said, I wish that the Puppeteer team had reached out to us because there's no reason that WebDriver Selenium can't operate with the new API. And that's what I want to show you. So I'm going to end with this. I'm going to end with a GitHub issue. So this is the Selenium project, Selenium 4 project. And we're looking at a feature proposal for Selenium 4, which is native DOM events, bi-directional communication, everything that we just demoed in Puppeteer, Playwright, and Cypress they want to bake into Selenium. So I think this is a really cool thing, especially to end on. We've basically gone, it's really full circle here, that Selenium is actually seeing the power of all of these things, specifically with mocking and network requests, getting real-time information, and making a new WebDriver API standard. So we're going to have WebDriver, and now we're going to have a new bi-directional web API, likely running on CDP. So that's how I kind of want to end it today. So we talked about Selenium. We talked about the problems that are inherent with Selenium. We rode the wave together. We talked about the solutions. We very quickly ran through the same tests in 3 different frameworks, and we ended with what happens next. And that's it. And thanks, everyone. That's all I had. And we have 1 minute left. Does anyone have any questions?
I did see that somebody posted a question in the chat. They said, "Does Puppeteer support the IE browser?"
Puppeteer does not support the IE browser, but I believe the new Edge, it supports it, or it will support it very soon, just because, as we talked about, Edge moved to Chromium underneath. Anybody have any other questions? Cypress, Puppeteer, Selenium, anything?
You talked about how Selenium was really expensive resource-wise. Do you have any idea of the resources that Cypress uses?
Yeah, that's a very good question. It's actually not. It's not that much cheaper from that standpoint, and the reason is it's everything you're doing is actually kind of intensive, because remember how I was looking at comparing before and after? It's literally putting every moment in time, which is very expensive. But what you get from that is when you see a failure, you can go right back to exactly where it failed and get a real-time view of your application to see how that worked. Which is, when we were talking about time, I think a lot of us spend a lot of time researching nightly failures, what went wrong overnight. And when you have that, you can save a lot of time, even if you have to pay the penalty in hardware costs.
Okay, that makes sense. You're saying it pays off because it's easier to debug after that.
Exactly.
Thanks.
And again, it's just so much faster. We already have more coverage than our old test suite, and we're still running everything in under 30 minutes, which is awesome.
I'm sorry. Just a follow-up question on that. Do you know roughly how many tests you're running? I'm just curious to see.
Oh yeah, actually, I think it's 130. And what we're so we actually let me talk about our test strategy. So someone asked about test strategy. Let me share my screen really quick. I didn't have, you see how rushed I was. I didn't have really a lot of time to talk about this, but what I wanted to, which I wish I had time to show off, is Cypress code coverage. So we only have 150 tests, and our test strategy is stubbing. So we basically put in, which I can show you my test. We're open source, so we're not giving any information that you should be able to get. But yeah, so you can see this one test here, we have stubs in place. So these stubs are interpreted by Cypress to basically know that this is a test that will exist in the future. But we do not have that. Not all of these tests are written. And that's kind of how we keep up with the dev team. It's we check in our code at the same time. We write tests alongside them and try to keep up with them. They go very fast. But so let me show you the number of tests that I have. But actually, I'm not going to. Let's go to Cypress. It's a problem with letting these things fly Chrome is they actually take over my Chrome browser. Let's go to our dashboard. Well, actually, let me answer the question directly. So it's pretty cool. So they have a parallelization model I want to talk about actually. If you look at your running tests, so this is my test we're running right now. What you can do is you can actually set it up so that you can run your same test suite from multiple Jenkins agents or different agents for whatever CI tool you're using. So you can say, we're running from one, but you can run from many. And it even gives you guidance on how much time you would save if you did that. Let's go back and see what you did. So if I had run all of these tests on 11 parallel instances, I would have saved this much time. And the way it does that, it's really cool. So it actually load balances all of your tests. Because you're using this dashboard service, it knows how long every single one of your tests is taking in the past. So what it does, it distributes your tests in a way to make it so it runs as fast as possible. So it usually sends your longest running test to one worker and then sends and divvies up the rest in between. You can see how it slices and dices it. So the way this would work, if we needed it, it's so fast we need it, but it would actually distribute the tests intelligently so that they're all finished as fast as possible. So how many tests do we have? You can see we have 750 stubs, and we have a total of like 750 tests, and 135 are automated. And the reason that is, I want to show off something real quick, is I have a PR open for this, but code coverage. We're throwing a wide net. We're not totally worried about every permutation of everything. And the reason is they allow you to get code coverage metrics from your tests to help kind of guide your testing. So it's the same code coverage that you get in your unit tests. So you basically instrument your web app, then you run all your tests, and then it gives you a guide of line coverage. It gives you everything you want to know about how much coverage do you have on your application via your tests, and that's how we're going to drive our tests going forward. We're not going to look at number of tests automated. We're not manual tests. No, we're not too worried about that. We are worried about how much of the application we actually.
That's cool. Thanks for that.
Again, I wish we don't have the PR and they won't accept it. The dev team has they have to put some things on it, but yeah, we're almost there. Any other questions? I could talk about maybe the things I didn't talk about. Test Cafe, Tycho are two other ones you guys should check out if you're interested. They are, I believe they are still open source, but they have the same freemium model. Also JavaScript based, also probably CDP based. Interesting. I didn't include them because obviously you saw how fast or how rushed I was. Not a lot of time to talk about it, but I checked those out too. I met up with somebody at a local meetup group here in Raleigh who had basically set up Cypress for 6 months. And then the guy that did it moved on to another company, so they moved to Test Cafe. And the guy said, the manager I was talking to said, we haven't noticed any changes in terms of bugs, defects, that sort of thing, and everyone seems to like it. So, Test Cafe is another option to check out.
Well, thank you, John. This was a great presentation, as everyone already highlighted in the comments, and thank you again for doing this. And as I mentioned before, this is being recorded, so I'll be sure to get the video posted and get the link sent out to all of you as soon as I can. But thank you everyone for attending.